American University in Bulgaria.
Okay, so welcome once again. This is the second lecture by Stanislav Gatsev, our Android expert, and today he's going to tell us about client-server communication in Android.
Yep. Hello again. So today we are continuing on the things I mentioned on Tuesday, and maybe the most important part of the application development. As I previously told you, every application, everything on your mobile device is getting more attached to the cloud and to the external world. We want to communicate. We want to communicate fast and reliable enough. So we need, if we are thinking on creating some mobile applications, for sure we should think on having some server side and communicating with it. Let me come here. Okay. So let's connect to the world. These are the main things which you should think of when you decide to use internet and network connection with your application. The first thing is our good acquaintance, the manifest. We put some permissions. The first one is the permission for the app to use internet. This is very, let's say, friendly permission for all of the users because they all know that every application uses internet. So it's completely okay to ask for this permission. Hello. The next one is the access network state, and it's actually needed for the second part here. The access network state permission allows us to check if we have a network connectivity and to receive some notifications for losses of this connectivity, to check if we are on Wi-Fi, 3G, GPRS network, or whatever. We have also 4G. So the next part, it should be something which you have in your code. And as it's a good coding practice, I'll show you the next time to put everything which is connected to the network communications in something like a tunnel. In your code, it should be one place. So in this one place, it's very important to check for the connectivity state. Why is it important? Because actually, if there is no connection, it's the most close to mind thing to just display a direct error to the user. As you know, we are creating. We should create, and this is the ultimate goal, to create a very user-friendly and intuitive applications. So displaying the right errors at the right time is very important. So having this snippet of code, what is it actually line by line? The first line is getting the system service of the connectivity service. This is a very common structure on Android. In the context, you have the constants for every service you can use. This is just one of them. It's completely normal here to have some casting. After that, you get the network info object from the connectivity manager, and you just check if the network info is not null or the network info is connected. In this network info object, there are the other things about Wi-Fi, 3G, and so on. So you can also have checks like this, but this is the very basic thing. Because you can also say that you don't support GPRS connection because it's very slow, and you can also say and we are not on GPRS, something like this. So let's get started. Yeah. Here we say I'll connect my Android application to the internet, like Bart Simpson. Hopefully you'll do it. Otherwise you have to write it at least 100 times. So the first step in writing network communication is from Android is actually to understand what network communication is and how it's done. As I'll show you in the end of the presentation, and what I'll show you next week in the practical part of our classes, there are easier and ways that are more structured, using some libraries and example codes. But if you don't know how this one is actually working on the bottom, you won't ever be able to use these libraries effectively, because I've seen a lot of people using a lot of libraries, and at the end it just come up to a big mess because of the thing that they're not knowing what they're actually doing. In fact, we've done a lot of applications only using the most lower. It's not the most lower part in the world, of course. You know it. It's a high-level language, and there are a lot of libraries below it. But let's say this is one of the lowest ways to do it on Android. So we should decide if we want to use the HTTP URL connection or the Apache HTTP client. Both of them are integrated into the SDK and are part of the programming interface. But actually the HTTP URL connection is the, let's say, recommended one after some version, the Gingerbread, but having in mind that Gingerbread is way older than you start to create real applications, so it's just the HTTP URL connection. There are good examples on HTTP client, and actually it also works good. But if you want to use it, my advice to you is get it from the Apache side. There is just a jar there, and you can integrate it in your application. It's completely okay. The thing is that at some point Google decided to just put away the HTTP client and don't support it anymore, and renew it and optimize it, and integrate the optimized and new parts in their SDK, because they just wanted to focus on something and to know, okay, this works, and most probably it was a lot of effort to support the Apache HTTP client. So the HTTP URL connection, what is it? It's actually something very similar and something adapted from it was called I think URL connection or HTTP connection, something like this. There was one of them was missing on the Java implementation, so it's pretty much like the Java implementation. So you can take a lot of examples also from there, but it's the preferred one if you want to start it directly. As we say here, both of them support HTTPS. It's the SSL encrypted connection, the security one. Streaming uploads and downloads, configurable timeouts about if you don't have responses just time out the request or things like this. They support IP version 6 and connection polling. So let's get to a little bit more theory. As I told you, I really think that if you don't understand what are you doing, you can't do it right. So I put some slides about actually what is HTTP. Maybe most of you know it, but I prefer to give you my view and what I think is very, very important to know in order to write a good and quality applications. HTTP is actually a request response protocol. It's just some bytes going on the network, but there is a very strict way of doing this. The client requests something and the server responds. It's the client and the server might be a lot of different things. Actually, the browsers they all work on HTTP protocol. You have the browser, which is making a GET requests to the server. Most of the times, if you're doing it from the URL typing part, from the address bar of the browser. Sometimes it can do another methods, but yeah, it uses the HTTP protocol, and as we say here, we have on the HTTP protocol we have the header with some configuration information, and the body with the information with the data that we want to transfer. Here are the two most popular methods on the HTTP protocol: the GET and the POST methods. There are a lot of differences between them, but the most important one and the most notable is that with GET, if you want to transfer some data from the client to the server, you have to do it in the URL as it's written here as an example. But if you use the POST method, the data is in the body of the request. So this is the header of the request, and this is the body. This allows the post request to be able to transfer bigger amounts of data. Also to transfer data in different and more formats, because on the URL we are somehow limited on the format we can use, because there are preserved characters. We have to escape some things and so on. And at the end we can encrypt and better hide something from the users if we put it in the post request. The thing which is most useful nowadays is the Restful architecture. It steps on the HTTP protocol. It's not a, let's say, it's not so much of an architecture than a list of rules of the way you should do your make your server operates, and of course make your clients communicate with this server. So the most important thing here, and this is something which is a very common mistake. I've seen a very big systems using they say RESTful web services, and having great mistakes there, like adding some data on the server using the GET request and things like this. Using this RESTful protocol makes your life a lot easier, because this is like a very strict and good way to know with which method you do what. So here the rules are, at least the rule I showed you, are very simple. With post you create a resource on the server, with get you retrieve these resources, with put you update some resources which you've already posted, and with delete you remove them. Actually, put and delete are pretty much with the same structure, and they work with the same way as post, but they're just called differently. So next we are getting deeper into the network operations on Android. How we are doing this? As we a lot of times discussed on the previous lecture, all network operations should be done on worker threads. For some reason, it's because of the user experience. After 4.0 version of the Android operating system, you're just obliged to do this. Otherwise, the operating system gives you an error, a crash. So, what I will show you here is the whole examples on the after that are connected to the some pretty common case. You want to get a news feed from somewhere on RSS news feed. It has a very strict format. Most of the times, or actually every time, it's an XML based. So we'll see how to get this, how to request for this XML, and how to parse it and show it in our application. So we have our async task, the thing which we know from the last time. We send the URLs from which we want to take the feeds, and pass it to a class called download feed, to a method called download feeds, and it gets as a parameter the list of these URLs. Why we catch this IO exception? Most probably because the download feed throws it. But why is it throwing it? It's throwing it because, and sometimes it might throw it actually, because the network communication is I/O communication. I/O communication is input-output communication. So every input-output communication can at some time be interrupted by loss of connectivity or something which spoils it. So it directly throws this I/O exception, and we should catch it. In compile time, your Eclipse will show you that you should catch this exception. So there is no way to miss it actually, but it's good to know why it's there and how to react. It's very good to react with a good and understandable message to the users again. Because on Android and every mobile device, the loss of connectivity is very common case. You can go into, for example, the subway or somewhere, and to have your connection dropped. And here we have some adapter which we are using for a list. I haven't expanded it, because most probably only by setting the data it won't update the it won't update the list, but the list view. But I'm sure that you know how to update the list view. So let's get to what's really happening behind this download feed method. So the download feed method receives the URL. Sorry, I had an error here. In the code, we don't pass the whole list, but just the first one. So the method receives just the first URL. So we pass the first URL and create this URL object. This URL object is a wrapper object. It gets a string as the URL itself, and wraps it up in order to be able to do the next things. The next thing is to open this connection. You are opening the connection to the server, and the opened connection is actually the class I told you earlier, the HTTP URL connection object. So after that, we'll use this object to execute our request. So what we do next is we are setting the read timeout and the connection timeout. What does it mean? The read timeout is the timeout between you received the response from the server and you have read it and handle it. We put this timeout in order to be sure that we won't get into some very big files which we can't really read, and go into like huge delays and to spoil the memory and the battery of the user, and of course the experience on our application. The next timeout is the more important one actually. It's the connect timeout. This is timeout which is from the moment we send the request and the moment to the moment we receive the response. What does this mean is that we are putting a timeout for our connection, because as we know, connection might be slow, and we don't want to have some connections which are 1-2 minutes and we are waiting for them. We just want to okay, we have some limit. If it's exceeded, we just want to close this connection and most probably try again or something. If one of these limits is exceeded, what will happen is that the code actually, the connection manager, the HTTP URL connection will throw an IO exception. We'll have it here, throw it upper, and then we'll catch it and show a good and friendly message to the user. So next we are putting the method we want the method of the request we want to execute. We'll do a get request. The do input, I'm not completely sure why it should be there, but so I'll just skip it. It's not something very important. I think it's I don't know really. And the next line, the connection, is the line at which you really do the request. So at this moment on, you're requesting the URL. Again, here, if there is no connection to this URL, or something happens with your connection between you've checked that you have connection, and here it will throw an IO exception. After we've done the request, actually this is a blocking operation. So before it will block our operation between during the request, and it will return only when we have the response. So if we are out of this method, we have received the response, and we are getting the response code. Response code is again something from the HTTP protocol. Response codes there are a lot of response codes. They all mean something, but the best thing here is to receive something between 200 and 210, because this means that everything is okay. There are also 404, which is not found, or things like this. So here is the response code. It's good to check this, and it's part of the Restful architecture, that from the server you should always receive meaningful response codes, and the errors shouldn't be like you receive response 200, but in the body of the response you receive, okay, it's 200, but actually we don't have this thing on the server. The response code should be the place where the server returns you if there is an error. So most of the times you should check your response code, have some handler there which transfers the application to different routes if it receives different response codes. Let's say everything is good, we have received 200, we get the input stream. Hopefully you all know what streams are. It's nothing with a water. It's more of a stream of bytes, and this is the most common. The streams are the most common objects used in Java to do input-output operations. You receive and send the data using streams. So we've received the stream, and we put it in a pattern, in a parser. What I said here is that I say get parser. What's my idea here? My idea here is that maybe in your application you might have a connection to some XML XML servers. You might have on one place some connection with JSON server. This is the hardest part, and here you need to think on, okay, I have this, I execute a request to this URL, I have to set the parser to this one. But actually the easiest case and the most common is that, okay, you have only one format of the responses, but actually the responses are pretty different, and you need even different base parsers, and you need and this base feed parser is very low level. It's just a class which is a parent of all of the others. So in this case, you need to set somewhere the parser on the manager, and after then get it and execute the command on it. This is called a command pattern that you receive. That you have a base class. You execute a command on it, but behind it we use polymorphism, and the different parsers are doing different things. It's a good way to do this thing here. At the end, we put this in finally part because we can have some exceptions also here. So it's very important, but we have to handle them here because we can't throw it. It's very important to always have the finally close and to close this stream, because in Java it's important to always close the streams and not leave some connections not finalized and closed.
Can I ask a question,
Yep.
please? Just to go back a bit, RESTful web services, they're just a list of recommendations.
Yeah, it's they have RFC.
Yes,
for
yeah,
this,
but it's just a list of recommendations,
Yep.
and it's up to you or us as programmers to actually specify which method. As you're doing up here, you're
Yep.
getting a file, so you're issuing a get. So
Yep.
yeah, okay.
Yeah, the RESTful is are a list of recommendations. There are a list of recommendations, and the idea is exactly this: to standardize somehow the easier HTTP protocol, because there are a lot of other architectures like SOAP and things like this. But why this is so popular? Because it's less bandwidth, less configurations, less dependencies. You can do it from everywhere, from every language. You don't have to do some big generator of codes and things like this. And it's very. You can actually also parse it by just byte by byte. It's very direct, but having it so flexible makes it very easy to be ruined and to go into some messes. So that's why they did this RESTful recommendations. And most of the servers which are up there now connected to mobile applications are RESTful. There are very little applications which are still using some SOAP services. We've done things like this, but it's as you can see, there is no SOAP implementation on Android. There are some third-party things, but they are not very good and not supported by the people who started them. And this is a pretty good example, and that's why we see that it's just not used. And the development on the other side, the RESTful side, is very much alive. But after all, we have a lot of different formats. We have XML, we have JSON. JSON comes from our favorite friend, JavaScript. It says it's an abbreviation from JavaScript object notation. They came up with it as a lightweight way to transfer data, and everyone adopted it. You can also do some character separated values, something weird which you want to use. There are many cases that having a custom way to transfer data is better for the case, maybe faster, maybe less bandwidth, things like this. But if you want to do it in some standard and maybe expose it or make it just easier and faster in the development, because you should always measure the pros and cons of everything. JSON and XML are better. You can also have some serialized objects. Just serialize the Java object and get it on the other side if it's again Java, of course, because in the other case you have some issues. There are also many more things, like there is a patch library called Thrift. It's very interesting. It's just again serialization of objects, but they did it like multi-platform. They support a lot of languages from PHP, Java, JavaScript, Objective-C, I think Python, even Python, which is not actually an object-oriented language, but again they have some support there. So they support a lot of things. The thing there is, as all generators, sometimes it generates a lot of mess, and you don't have the opportunity and way to just modify it in your own way. It's just the way it works, the library. There are a lot more you can find everywhere. It's really up to the case, the thing which you use. I'll show you the most common ones, the XML and the JSON, and show you some examples of how we really parse these formats. So, as we started, we did a request to an RSS feed. It returns the response. The response is well formatted XML, and we need to parse it.
Why do we need to parse it?
Because you want to show it to the user somehow. You don't want to just show him tags and here we don't have attributes on the XML, but maybe at some point we'll have attributes. You want to show it in a good, beautiful way, to show every message in a different pop-up with some style and things, and you want to parse this logic into object in order to use it easier and properly in your code. Actually, all the network communication works like this. You have the client. For example, it wants to post some data to a server. On the client side, most probably, what it will post is some kind of object. It serializes it in some format, XML, the ones we discussed, and send it. After that, the server parse this format, do whatever it's needed. Again, have some object which it wants to send as a response, serialize it, put it on the network. At the other side, the client gets this response, and we are at this point. We want to parse this response and again put it into some object. This is how the thing actually works. So I can't expect you to understand, and this is not the case, to understand what are the tags and what is their meaning. It's just an example of an XML. So there are several ways to parse an XML on Android, and actually I'll show you three types of parsing, but at the end there are two types which are general in the programming as a whole, the Sax way and the DOM way. I don't really remember what the abbreviation was for. The DOM was again something about object.
Document-object model.
Document. Thank you. And do you know the Sax one?
I forget.
But the main difference between these two is that one of them, the DOM, is getting the whole response, put it into some, actually this document object model, and after that you can use this data. The Sax one just goes through the response while you're receiving it, and you are the one who should handle what's in this response. And of course it gives you some callbacks on this happened in the response and so on. I'll show you. And the third one is actually an Android way of modifying Sax a bit to make it a little bit easier and handful for usage. So if we want to use to parse our response with Sax, as I showed you earlier, we have this Sax feed parser, which is a child of the base feed parser, at which we code parse. We set the feed URL. I don't know why. I think it's needed for the parser, and we set parse. At the parse method, these are just things that you should do. Just create these objects, and in order to parse the response, you create the parse factory. Actually, get it because it's a static class and most probably a singleton behind it. From the factory, you construct a new Sax parser, and you create a new handler. Actually, the magic is not done in the parser but in the handler. The parser is just the thing which sends which executes the method which calls back the methods of the handler, but your code is in the handler. There you handle what's in the response. So you have the parser, you say parse, put the input stream. Okay, it's a little bit messy here because the input stream should come from the example, but let's say we put we pass the input stream to here somehow, and we also pass the handler to the parse method. And in the end, we just get the messages. Get messages is just a custom method which you created. You can and should of course call it differently if you want to get something else. It's just the method which gets the already parsed objects. Okay, so what's behind this handler? On the Sax handler, you receive callbacks for different parts of the XML. The parser understands where is the start of the document, where the start of the attributes, where the start of the tags. It gives you a callback on every character. So the default way of doing this is creating a string builder. This is string builder is mutable, like a mutable string, because you know the string is immutable, and if you change something in the string, it just creates another object, which is not very memory friendly. So we have this string builder, and we append the characters to the builder. The idea is to on every character to sum up the things which are in the response, and at the next callbacks, they are mostly in the end element callback to get the things which are already summed up in this builder, and to restart it. For example, we are at the end of the title tag. If we are at the end of the title tag, we know that, just to note, the characters are not the tags or the attribute names or things like this. The characters are just content, like the content of the tag, content of the attribute, or so on. So you don't need to worry here that you should after that from the string remove the tags and things like this. You receive just the content here. So in the builder, we've already summed up the content of the title tag. Here we set on the message the title of the title which we received from the response. There is we can't end more than one tag at one time, so we will just go directly here and set and reset the builder. This will be done on every end tag. We will check which is the tag we are ending, and if there is something in the builder, we will just put it at the message. But where this message comes from, we use the start element. We check if there is an item tag on the start, and on every item we create a new message. So this is pretty much the way it works. The thing is that the parser goes through to the response, callbacks when there is something interesting for you, and you have to check what was it and how to handle it. And the other tricky part is the builder, where you're summing up the content, and when you understand from the callbacks that this content is whole and there is nothing more, you just put it on the right place. Do you get it? Good. Next part. Most probably a little bit easier for understanding, but after that we'll discuss what do you think is better. So the DOM way. We have here mostly the same structure, but we create this factory, create new document builder from the factory, and again parse from the document builder. When we parse the input stream, what will happen on the API level is the following. Mostly the same thing which we did with the sex handler will be done with the DOM handler, except for that the DOM handler doesn't understand that the title tag is about title. It just says it's a child tag of the message tag, and the message tag is just child tag of the messages tag. And understanding that structure, it creates a tree. It creates the root of this tree is your XML object, and after that, in our example, we have the messages, object. In the messages objects, we have list of messages, like leaves of this messages object, and in every message object we have its leaves, which are its properties actually, which are again tags. In the DOM model, we call them nodes, and the lists are called, like the messages lists are called node lists. So there, in the DOM structure, there is a very strict way of parsing the things. It always parses the things in the same objects, and you have to go through this tree and to find the things which are important for you. For example, what is going on here? We have the root element, which is the XML, or in this case most probably it's the messages, but I'm not sure that in the example there is messages. Tag. There's a channel. Yeah, there is a channel which is actually the messages one. So we get the root, and we get the list of messages by tag name. It's the same in the sax parser where we checked for the beginning of a new item. So that's the thing. Item here is just constant for item. There is no item out there. Item. Okay.
There is.
Yeah. Item. Yeah.
There is item type.
Yeah, there are items. In our example, there are 2 items. So we get these items, and as I told you, it creates nodes for them and puts them in the nodes list because it understands that this is a list. So we get these items, iterate through them. On every new iteration, we create our message object because we want to transfer the node into a message. Get the right item from the iteration. It's just a for loop. And get the list of the nodes which are in this item. As I told you, these are like the leaves of the item. So again, next we iterate through this node list. The nodes here are actually different because their name is the name of the tag, and we are checking the name of the tag and just get the value of this nodes. So it's pretty much the same, with the only difference that here, before starting the real parsing, we've already have everything there. We have the whole structure with the whole content of this structure. This was the end of the parser. The description, the pub date, this is just another text, and again we add the message into the messages list, and at the end we just return the messages. Okay. The last one of the parsers, I'll be very quick here, is the pool parser. As I told you, it's just a modification of the sax parser. The idea is that you don't have to create the handler and the callbacks. It's just giving you this callbacks in a event, as they call it, and you just receive this you receive every event in this loop, while loop. The idea here is, and why is it called pool, is because on every other tag which it tries to read, you should to continue the parsing, you need to call parser next. The idea there is that you're again, like in SACS, going through the tree one by one, but at some time, if you say this is completely enough for me, you can just say stop this, break, and return, and stop the parsing. The idea is that you're pulling by saying, okay, give me next, give me next, give me next, give me next. You can also, if you want, like skip some parts of it, like say sometimes next. And I think there was some other helper functions. So it's pretty handy, but again, it's pretty much the same as the SACS parser. Okay, let's just go a little bit here between the things we discussed. What do you think? What should we use in one Android application, and why should we use it? What will be the pros and the cons between the DOM way and the SACS way?
Well, the SACS way is like the parser in event-based, while the DOM is like a tree.
Yeah, but what will happen at the end? What will be the impact of parsing the one way or the other?
The DOM way, you're creating this hierarchy, this tree in memory.
Yeah.
So you're using up memory.
Yeah, actually at some point you're not only using memory, but you're using also runtime.
Yes.
You're using your processor and this delays thing. So at some point the DOM way might be slower and more memory consuming. Even at cases which you don't need the whole response, because there are a lot of cases like this. You parse some standard XML which comes from, for example, some of the university servers which are sending just everything, and you just need some of the properties there. They're a lot more useful will be the SACS way. But for example, our case, the RSS feed, we need everything. At some point, we'll again use the whole thing, the whole tree. We can just do it by DOM. At one place, it's maybe somehow easier to be implemented. On the other case, of course, going through the stream and doing some computing there, it might get us into a little bit lower, slower way of parsing the whole response. So if you need everything and you are completely sure that it's just a small response, not something like megabytes or something like this, maybe it will be easier to use DOM. But in most cases, the SACS way is more suitable on Android. At least from my experience, mostly we've used SACS. We've also used the pool parser, but as I had some experience with Java before, it was a lot easier for me to just go with SACS and just use it. It's very, if you understand it as a concept, it's very easy and straightforward. So the next part, which is Actually, maybe the most used and the most common format nowadays, the JSON, is the way to read JSON files. I don't know if you've seen how a JSON looks like. The biggest difference here is that you don't have these tags and everything. There is the information is a lot more compressed. You just have objects and lists, and you just have to know where these objects and lists are. So this is with the square brackets.
Curly.
No, I'm talking about the square ones. Yeah. With the square ones, you show that you have a list. Like here, you have a list of some kind of geodata. With the curly ones, you show you have an object. You can also have an object by having just one property of this object. If here in the geo we wanted to have like more complicated objects, we should have like curly brackets and put some other properties in them. So this is JSON format. Again, we receive it in like this in the body, and we have to parse it. It's a little bit different example because I get it from the Android site. The JSON reader is something new. And something which they introduced lately on the Android platform. Why they did it? Before that, they had this JSON objects, and the way you parse the JSON was the following: you receive the response, you put it in a string, and after that put this string into JSON object. And having it into JSON object was pretty much the same parsing as the DOM way, which was somehow memory consuming, especially the part with the string, because creating a string, as I told you, it's immutable object, and it's very memory and processor time consuming. So they decided to make it a little bit different, go into something like the pool parser, again with pulling what's next and so on. I have it as a reference how it's actually done, and here is the example. Again, as in the XML parsers, we have something called reader here, but it's pretty much the same as parser. We pass the input stream to it and read the messages. Here, exactly the same as in the pool parser. The reader reads every new object, which can be a list or an array. So you start to read, like begin the array, and put everything into a loop to pull for the next object. The next part is actually how it's done inside in the read message. You pass the JSON reader, and again with the same in the same way you start to read the object, not the array, with begin the object, and get the next property from the objects. At the end, you you construct your message and pass it back. This is pretty much the case. They did it exactly because of the thing that the DOM way was not very good for JSONs, especially the thing with the string, and we had a lot of problems with memory because now it's better as the hardware got bigger. More memory allocations are allowed, but before there were limits like 16 megabytes of allocation per application, which makes the things very hard for us because this also includes some images and things like this. And if you have some images in the memory and receive some response of 2 or 3 megabytes, you just receive memory crashes, and the memory crashes on Android are very nasty because you can't catch it for them. You can have some listeners for them, like listen for the memory is going low, think of what you're doing, but you can't really say here it will crash, and you have to be very cautious about the memory there.
This is specific though for your JSON example. I mean, you're looking for text like
ETO. Yeah. Actually, all of these parsers are very much connected to the format, not the format, but the format of the response.
Yes.
Because if you don't know it, you can't have it. There isn't like a standard way of doing this. The things which I'll show you at the end and tomorrow and next week are actually doing this standard way by using some annotations and looking for some classes. This was some this is the way we read for the due date, again in the array. So the pool parser here is very easy. You read when you start to read an array, you begin to read an array and end the array. When you begin to read an object, begin the object and end the object. Okay, and the most exotic part, the libraries. My advice is to use libraries. Don't think on I should do everything by myself and it will be better. Most times, yeah, maybe you can do it better. Maybe you can do it a little bit more effective. But at the end, you should measure the things, and you should measure that. After all, libraries like this, the Volley one, they introduced it the previous year on the Google I/O. Was a thing done by developers, most probably a lot more experienced and a lot more into the thing than ourselves. After all, this is something used by a lot of people. So if there are some really nasty problems there, most probably there will be solutions for them. And after all, there are some patterns and some things there which can be which are very good to be really reused. Actually, before having Volley, we had most of the things which were developed in Volley written by ourselves and with our internal company library, which was used for every application. We said we have this library, we implemented most of these things. Because maybe these 4 things are somehow not very self-explaining, but are things very important, especially the canceling the request, because it's not very easy way to cancel some request if you've already sent it. There is no very easy way to queue your request. You have to optimize it very good. This is the worst part, the caching and the memory management of the requests and the responses. So all of these things come directly to you using the Volley. The other good thing is that it's after all, it's a Google's product, and it saves you a lot of time. It saves you a lot of bugs and problems. It gives you more time to think on creating a really good product, actually, on the higher level. But again, I'll repeat this: don't give your 100%. Don't rely on 100% on these things. If you don't understand how they're using, you won't understand how these things will work on them and how they will be really useful for you. So the things before that are very, very important. The next library which I want to show you is JSON. It's again Google's product, but now it's open source. It started as our product, but in Google, and as our libraries, but in Google, they just said, okay, we want to have something which is standardized for parsing JSONs, and we want to use it everywhere. And they just developed it. At some point, decided to put it open source and to develop it for different platforms. It was Java based, but works smoothly on Android. The idea of JSON is to make all this parsing somehow transparent and easier. It's good memory optimized. It uses this. It doesn't use the pool parser of the pool parsing type of the JSON parsing on Android. It works directly with the stream, but works this way and doesn't use a lot of memory and computing power. But yeah, I will show you these two next week. On Tuesday, we'll have some examples using exactly Volley and JSON, and we'll see how it really works, and we'll connect our not mobile devices, but our mobile emulators on the computers to the internet. Okay. Do you have any questions which I can answer? If I can't, please don't ask.
Anyone? No? Don't be shy.
Okay.
Okay, thank you very much.
Thank you.
This program is brought to you by AUBGTalks. For more, please visit us at aubg.edu/talks.